Good morning, everyone. My name is Dragan Petkovic. I work for Oracle EMEA as Business Development Manager for Security. And welcome to the keynote of today, Zero Trust and why security should be always on. So what is Zero Trust security? Well, it depends whom you ask. One thing that we can agree that the term itself came from Forrester Research, and it was describing a new paradigm as opposed to the classic security model, which is more of a perimeter security, where firewall was your key security device, and you trusted everything what was behind the firewall and didn't trust anything what is in front of the firewall. Zero Trust actually puts the security controls on each and every layer. There is a joke which now is more than 1 year old, and it asks who is in charge of digital transformation in your organization. Is it Chief Marketing Officer? Is it CTO? Chief Technology Officer? Is it CIO even? Or D, is it COVID-19? Jokes apart, the fact is that the pace of digital transformation has been accelerated by 3 to 4 years due to COVID. More than 50% of the customers prefer to use digital channels. And even after this lockdown and pandemic ends, more than 50% of interactions will remain digital. To give you an example, at the beginning of the pandemic, we created a remote workforce solution, which gives ability to organizations to have their individuals working remotely, accessing on-premise resources without being able to use VPN, but also in a safe fashion. We predict that 20 to 30% of all workforce will remain remote even after the lockdown ends. On the other hand, we've seen the tremendous rise of different data breaches due to the pandemic. The fact is that some analysts like Gartner predict that 95 to 99% of all data breaches in the cloud will be due to the configuration error. Traditionally, and you can see it in this slide, when we talk breaches, we normally think about confidentiality breaches, so data being leaked. But there are other types of breaches that we need to take a look into, and those are availability and integrity breaches. I'm going to spend more time in the next few slides talking about it. Here is an example of availability breach, this time for a sports watch manufacturer, and it's caused by ransomware. So users were not able to get their health and fitness data for more than 2 weeks. Now, sport watches are more and more used as healthcare devices, and therefore breach by availability might create serious consequences. In this particular case, it is believed that the victim of this ransomware attack had to pay between $10 and $15 million to get their data back. For integrity data breaches, I can start with my personal example. The bank I was using had incorrect Emirates ID expiry date, and as a result, I was not able to access my funds for almost a week. It was very unpleasant, but it can get much worse than this. So several US security equipment manufacturers had their patches contaminated with malicious code. As a result, a large number of organizations in the US public sector was compromised. This is the typical example of supply chain attack. If you translate this to the cloud, there are several questions that you have to ask yourself. How safe is the virtual machine? How are the credentials being used? And I'm going to touch this more in the coming slides. The other one is how does your cloud provider recycle the resources? We witnessed that there were several attacks on resources done by malicious code left in the BIOS of cloud hardware. So one thing that you need to make sure is that your cloud provider has a gold standard and that it completely scrubs the resources before it gives them back to other customers. When it comes to cloud security, this map is probably the first thing that you are going to look into. So in a cloud security context, the shared responsibility model conveys how cloud service provider is responsible for managing the security of public cloud, while the subscriber of the service is responsible for securing what's in the cloud. But complexity creeps in due to differences between the different type of cloud services and in some cases variation between service providers. Additionally, some domains such as configuration, management and compliance are typically shared, with both parties having substantial mutual functional responsibilities. So if you look into this model here, on the left-hand side you see on-premise, where customer is responsible for pretty much everything from physical security all the way up to the who has access to what. IaaS, as the lowest level of abstraction, gives certain responsibilities to cloud provider, and this is from the physical security all the way into the virtualization. So you as a customer would be responsible for everything from the operating system and above. PaaS gives the additional layer of abstraction and isolates the guest operating system. So as a customer, you would be responsible for application data and user access and identity. Now when it comes to SaaS, which is by far the highest level of abstraction, there is still some responsibility that's left with the customer. So as a consumer of the cloud, you are always responsible about data you're putting there and also about who has access to what, which most commonly we refer to as user access and identity management. Let's take a look into Oracle and KPMG Cloud Security Survey from 2020. As more data is stored using cloud services, including that deemed to be sensitive, cloud data security becomes increasingly important. To that point, 89% of our research participants shared that at least half of their cloud resident data is sensitive. Unfortunately, three trend lines are heading in the same direction. First, the percentage of cloud resident data considered sensitive is increasing. Second, increasing confusion over the cloud security shared responsibility model. And finally, data loss attributed to confusion over the model. On the last point, the year-over-year trend is troubling, more than doubling from the 23% who reported last year that confusion over the shared responsibility model led to data loss to nearly half of those who reported the same previous year. So what can we do about it? In Oracle, we looked into, can we bend this shared responsibility model in customers' favor? And if you look into different statistics by analysts, for instance, like a Gartner, which predicts that almost 99% of all the data breaches in the cloud will be due to the customer configuration error, we are seeing automation as the key in enabling safer clouds. In a traditional on-premise world, security vendors are usually niche players. This will no longer be acceptable in the cloud, and we predict that cloud providers will eventually become security vendors as well. Now, if you look among CTOs and CSOs that we interviewed, there is an unease with the lack of visibility, worry about the potential for data exfiltration by internal and external threat actors, and concerns about compliance. The issues don't end there. We also find rather than truly integrating security and compliance in the cloud, security often remains an afterthought, with organizations either bolting on traditional on-premise security controls in a piecemeal fashion. Companies need more proactive and comprehensive approach in order to achieve the right levels of control implementation, coverage, and maturity across all areas critical to effective cloud security. So what would be the correct security approach? In fact, there are so many layers of architectural choices and capabilities that comprise Oracle Cloud Infrastructure Security that we need to organize them for better understanding. We want to talk about the security of the cloud. This is the architecture, operations, and those aspects that are baked in which customers don't see, especially on the physical network. Then we will look at the security on the cloud. So those are controls which OCI itself uses to secure the infrastructure and control access, and how those same controls are exposed for customers and tenants to use for enforcement of warranted access and enforcement of secure business communication. Finally, we examine some of those controls and how they are applied across customers' estates, and that can span on premises, third-party cloud, and it's inclusive of a customer-owned security stack and investment in pure-play security tooling. If you look into it, most of customers will have multiple clouds, so cross-cloud security becomes increasingly important. We usually refer to this as a single pane of glass control. So not all clouds were born equal. So to understand better the Generation 2 cloud, let's take a look first at the world's most common cloud design and what are you likely using. So Generation 1 clouds use a hypervisor that combines or comprises the functions of server and network virtualization. Access to the one gives the access to another. Now, on the contrast, the Generation 2 cloud has decoupled server virtualization from the hypervisor and encapsulated its own hardware and software hardened layer. This design is a fundamental distinction of Generation 2, and it's implemented OCI-wide. Every data center of Oracle has the Generation 2 clouds in all regions, regardless where you are. This architecture results in lower overall risk for tenants of OCI, and here is why. Traditional thinking was that virtual machines are safe and secure. Now we know that virtual machines can be attack surface for the cloud. A weapon of a bad actor if it gains persistence on a VM with the objective to move laterally, finding high-value targets and data and ultimately exfiltrating this information for gain. Access to the hypervisor is a key step in this kill chain. Hypervisor breakout or hyperjacking has been demonstrated of multiple hacker conferences proving Generation 1 clouds vulnerable to this attack. Now you can think of it as a noisy neighbor. Now if you have a noisy neighbor, obviously you wouldn't be able to sleep, and this is equivalent of different tenants sharing the same hypervisor and one using much more resources. Now if we move into another example, that if one tenant has the infestation of the vermins, then those vermins can spill into another apartment. And this is exactly what's happening with Generation 1 Cloud. So if you have one virtual machine being compromised due to bad security or whatever reason, it can subsequently compromise all other virtual machines, and it can spill over the unprotected hypervisor into another tenant and compromise tenant that might have a good security. As a differentiator, let's see what's going to happen in Generation 2 Cloud. So as you can see, still if you have a bad security, your virtual machine is going to be compromised, but attack is mooted. And there is nowhere to go. So the hardened isolating network virtualization layer makes takeover statistical impossibility, and the threat is contained within this server. So let's see what you would do to protect really sensitive workloads that you put in the cloud. Say you're using a traditional cloud. So those clouds are usually reactive and they do alert you, but you are left with a hard, slow, and manual task of killing the threat yourself. In most cases, if you want to automate it, you will have to resort to tools like CASB or Cloud Access Security Broker. Now, we've decided that this functionality should be built within the cloud, and hence the Cloud Guard. Cloud Guard constantly watches and collects data from the audit, data safe, OS management, logging, and network flow logging services. So we do analyze the data and detect threats and misconfiguration. Yes, it can still alert you, but better yet, it can automate it. It can kill threats without any human intervention. We've already established that 99% of all data breaches in the cloud will happen due to end-user error. So let's talk about a place where security is not an option, and those are maximum security zones. Imagine that you define the golden standard of security for your organization and that you cannot deviate from these standards. Those are maximum security zones where security is always on and easy to establish. So what it does, first of all, it's a zone within your environment where security is not a choice, it is always on. You cannot switch it off. Resources launched in this zone will be on dedicated infrastructure with the highest level of data encryption and network security. So instead of having the additional long list of security tools, instead of doing the additional hardening on one by one, which is very complex to set up and very prone to error, you can define your golden standard and immediately all the resources that you provision and deploy will match this golden standard. This is what we refer to as security always on. How did we come to those conclusions? Take a look into the following infinite loop. It is about OCI Security Team, which is a dedicated global team of experts that ensures services and customer tenancies on OCI are protected. This team spans both secure development, secure operations in a virtuous circle, when the findings and the knowledge of the former inform the practices and work products of the latter. Oracle develops and runs thousands of services on OCI, including SaaS and PaaS offerings. Our team helps developers understand security architecture, follow secure development practices, as well as scan code both during development and at runtime to reduce errors and risk embedded within. Once deployed, our secure operations team takes over conducting the activities that will detect and respond to the risks. So what is the conclusion of today's session? First of all, is use zero trust security principle regardless if you deploy on-premise or in the cloud. It is a concept that is validated by several national security frameworks and you should be adapting it. If you'd like to know more on how we are doing it, check our blog posts. Second is, do not simply rip those classic on-premise security tools and expect them to work in the cloud. Chances are they might not. Check what are your options with modern security tools. Third is practice secure configurations and have the means to enforce it. Think about maximum security zones. Think about the zone where security is not an option. The fourth is we already established that most of the data breaches will happen to the misconfiguration errors done by humans. Try to eliminate it. Try to automate as much as you can. We start automating using our autonomous database, and we've seen this is the way forward. And you're going to see more and more tools from Oracle being automated. And the last one, make sure and remember that regardless of shared security model that you use in the cloud, you will always be responsible for identity management. So identity management is your last frontier. And this goes hand in hand with modern technologies like 5G. Regardless where you are, actually users will want to have the access. So make sure that if you can control one thing, make sure that you control who has access to what. I'd like to thank you for your time today, and I will stay during the day to answer any questions that you might have. If you want to know more about database security, please stay for the data safe sessions delivered by Luke. Thank you.